Hi, and welcome to our Spinnaker Summit 2020 presentation about all things scaling and tuning Spinnaker. I'm Chuck Lane. I'm a lead software engineer on the Salesforce continuous delivery team. We support all things Spinnaker at Salesforce, and joining me today is a good friend of mine and a valuable member of the same team, Trey Morris.
Hey there. A couple of years ago, we started a Spinnaker proof of concept for creating a system capable of managing Salesforce applications and services across multiple public cloud substrates. At that time, we had some small goals. We wanted to use Helm charts and Terraform for deployments to make it easy for our devs. We wanted transparent account management for accountability, and we wanted the process to be convenient and repeatable. We had meager scaling goals for the proof of concept as well. Our only real hurdle here in the proof of concept was the tooling to manage the number of counts. Luckily, Chuck was around.
So yeah, I went to tackle account management and took a first stab at that. But as we grew out the proof of concept, we ran into some other scaling issues. We had all of the Spinnaker microservices deployed via Halyard the first time. And what that meant was we had a pretty fragile data layer. Our services were backed by Redis for the most part, with the exception of Front 50, where we used an S3 object store. We had authentication, but no authorization, meaning we didn't really have a good way to tell who had always done things. The pipelines themselves were mostly made by hand and not necessarily codified or repeatable. We had a lack of metrics in the system, so we didn't get a real good idea of success around pipeline executions or even just testing the health of the Spinnaker services themselves. And finally, back to account management. When we wanted to add new accounts, we had to restart at least the Cloud Driver service, which led to a lot of issues around stability. So we took the information from the proof of concept and we made a plan to scale up.
These were our main needs. We had issues with traceability because we would lose pipeline execution history. We didn't have any execution accountability, so we wouldn't know if certain users or teams were running very heavy loads that were causing us trouble. Our microservices definitely needed some improvements in durability and availability. We needed lots of metrics. We need those pretty charts. We need all that data in an easily consumable way so we can make decisions, so we can see, how many pipelines are running this month versus last month, or are we bumping up against some of our scaling targets? Do we need to make databases larger? These sorts of things. And we really wanted our executions to run reliably. If it took 10 minutes last time, we want it to take about 10 minutes this time. We don't want it to take 10 minutes last time and 2 hours this time. That just tends to look bad from a user perspective. So we have some solutions that I'd like to dig into. The first solution was really putting Sql everywhere. It became obvious pretty quick that Redis wasn't going to be the way. So we started by moving our favorite microservice, Cloud Driver, to a MySQL pod running alongside Spinnaker. Orca, Front 50, and Echo soon followed. And it became even easier once we migrated to managed SQL instances. We still noticed a performance benefit by using Redis for caching, and we needed to enable persistent volumes to make that usable. As things scaled further, we started to tune the SQL usage from the client side with the Hikari connection pool settings and service timeouts. And we're still tweaking those values a little bit. We're playing around with different sizes of pools, different numbers of microservices, and sort of, playing around with, do you want 5 cloud drivers each with 20 connections? Do you want 2 cloud drivers with 100 connections? What's the best way to go here? What we found is that Sometimes as load changes day to day, certain values make more sense than others. And so we're really just playing around with connection pool settings at this time.
So next we're going to come to the authorization layer. Basically, for any of you that have gone and implemented fiat authorization, what you're definitely going to need is a source of truth for the role names as well as who the individual users are. In our case, we do this via LDAP, but you could also use SAML groups or GitHub teams. Next is really figuring out where you're going to be able to set the gates for authorization. That's basically controlled at the application and the account level right now in Spinnaker. You have your create, read, and write permissions that are pretty much everywhere. And then recently they added an execute permission that also allows you to gate the ability to execute specific stages for some cloud driver types. They recently also added the ability to use something called composite types when it comes to the application permissions themselves. And what this allows you to do is basically prevent users from creating their own applications unless they live in one of a certain set of roles that you want to give the ability to do those things. As you go and you create different entities inside of the system, we found that there were some issues around reliably getting the permissions cache to have appropriate roles assigned to it for new entities. So, for example, you would create an application, and then immediately it would say that the user didn't have read application to the application that you had just created. So to get around that, in some of our automations, we built a call that would force trigger the roles to sync inside of fiat. In addition to that, there are a couple settings allow access to unknown applications and restrict application creation. Those are Spring profile settings that we had to configure appropriately to get just the right mix of visibility while retaining the authorization goals that we had. In addition to that, as we scaled the services up, fiat can be particularly noisy. Just about anything you go to do inside of the UI, it's going to go ahead and request, make a call to fiat to verify that you have authorization to perform the action that you're trying to take. As a result, like I said, these services can get very chatty. And so as we started to see timeouts when we scaled things up, we had to go into the individual services and adjust the fiat services Spring profile settings for each microservice to allow the appropriate time for the connection and the communication to take place, both between inside the application and with our LDAP server, where we would actually read the roles.
We leveraged the power of Echo to give us insight into pipeline and task performance, as well as other metrics. As I mentioned before, we needed the ability to see what we're doing. We didn't have a whole lot of an idea what users were running what, how often, when they were running things, or any of that until we started using Echo. We also added some user experience tweaks in there too. Users can now track executions with Slack notifications and things like that. And we have some triggers for pipelines in PubSub, and you can also use PubSub as a message bus.
The Echo events gave us a good deal of information about pipeline executions, but in addition to that, we also needed information about the Spinnaker service health in general. To get this, we use a combination of health checks and liveness probes in Kubernetes for the services, as well as the monitoring daemon that is provided by Spinnaker out of the box, with Prometheus specifically as a backend data store. The nice part about that is it comes with a set of Grafana dashboards out of the box. Now, your mileage may vary there. There were some things that we needed to tweak to get them to display exactly what we needed. But once we got those configured appropriately, it's provided us valuable insight as far as what the health of the services are themselves, and give us information about what the work queue size is for Orca, as an example, or where we're experiencing errors within the system as the microservices talk to one another. In addition, the cloud driver metrics can give you good information about the latency or the amount of time that calls to your cloud provider, AWS or GCP, are taking, and really just gives you a wealth of information about exactly what's going on under the covers in your Spinnaker services. So it's valuable, and it's definitely something we would recommend.
One of the low-hanging fruits that you can easily get to is by enabling Redis persistence. We had quite a few issues, as you can see. A gate session loss was a pretty big one, and losing execution history was pretty rough as well. And adding persistent volume to Redis pretty well fixed all of them. It took us from losing that pod being a blip or being an outage to a blip. And essentially Kubernetes would recover in a way that it couldn't do when you lost all of the Redis data. We also tweaked the Redis connection pools over time, kind of like we did with SQL. We're still playing around with what size of pools make the most sense based on our Redis usage. Right now we're using Redis in a pod, but we'd like to move into a managed Redis instance at some point in the future.
So now I'm going to talk a little bit more about some of the hidden knobs that are present that we use to configure our service and get the best level of detail out. First of all, for each of the services that are Spring Boot based, which is everything but Deck, you have the ability to set a logging level for individual classes inside the service. What this means is that you can set the logging level to debug for any of the Spinnaker classes. So that would be like either the cloud driver, Orca, or even some of the underlying libraries like Keiko and Cork. And you can set the log level for those to debug, which sometimes will help you gather extra information to troubleshoot issues around integrations or other hard to track down problems. In addition to that, there's a set of Spring Framework classes that you can enable debugging for. You do that in the same way. You set your logging level and then the name of the classes. So like org.springframework.security to debug, and then you can get valuable debug information about the underlying Spring Boot platform that the service is running on. This is good for helping to track down issues around authentication and authorization, other parts of the service that aren't necessarily part of the Spinnaker code, but instead where Spinnaker may farm it out to a library to handle the heavy lifting there. And finally, you can set just a root level of debug, which could be useful for getting information about the Tomcat service that actually fields the HTTP and HTTPS requests underneath the service, and information about the headers and things that are passed back and forth. In addition, it's sometimes valuable to be able to turn those off as well. You may run into a particularly chatty class that just gives you too much information in info mode. And so sometimes it's useful to be able to pick a particular class and say you only want to see error log messages from that class. One other lesser known feature is around the Spring Boot health checks. So out of the box, the way that the health checks work is it'll simply give you a return message that says either the status is up or down. In practice, what we found is that this wasn't enough information in a lot of cases to determine what was causing the service to go down. So there's a management endpoint health show details always option that you can set in your Spring profile. And once you have configured that in your Spring profile, then when you make a call into the health check endpoint, it will break the health check down into the various components, and you can see which part of the health check is succeeding and what part is failing. This is good if you have a service, especially that's flapping or something like that, and you want to determine exactly what the problem is that's causing it to flap. Sometimes this can help you capture those kind of lightning in a bottle failures and pinpoint the root cause of the problem. In addition to that, there is a set of Spring management endpoints that it's also been valuable for us to look at. Basically, once you have used the statement here in your Spring profile to expose access to these web points, then there's a number of endpoints that you can call inside of the Spring framework to get a good idea of exactly what the underlying layer that's running underneath Spinnaker looks like. And this has helped us troubleshoot all kinds of issues, as we've learned that sometimes it's better to look at Spinnaker as a set of Spring Boot applications instead of just trying to look into the Spinnaker code for all the things to solve the problems that you run into. So a few of the endpoints that we found to be very useful, both in troubleshooting as well as development, are the /beans endpoint that will help explain exactly what beans are loaded by a particular service. This can help you understand if you don't have a particular module or part of the integration in a service that isn't turning on. The beans endpoint will explain to you why certain parts of the code, certain components got loaded and other ones didn't. The config props endpoint displays all configuration properties for the service, as well as /env, which displays the properties particularly from the Spring configurable environment itself. And I'll talk more about those on the next page. Kind of how those relate to the configuration of the service. And there's also a metrics endpoint that will help you get some metrics out of the application, particularly from the Spring Boot side of things. It's not that they don't 100% match up with what comes out of the spectator metrics endpoint that feeds into the monitoring daemon, but sometimes they can be useful for identifying bottlenecks and other things. And there's a whole set of Spring management endpoints besides these. These are just some of the key ones that I called out. But yeah, I'd take some time to look at those and see if there are other ones that you can use to get a better look if you're running into issues. A big part of scaling and configuring the system correctly is determining what can be configured and extended. Inside the Spinnaker code, this takes the form of a lot of configuration classes and configuration properties classes. Essentially, as you go through a module in the code, in a lot of cases, you'll come across a config folder. And in this config folder, there will be a class that ends in either configuration or properties or both. And in these classes, they'll usually be annotated with a configuration attribute. And basically, what that means is that This is a class that is bound at runtime to the Spring profile to define the individual properties for this class. Back to the slide that I was talking about before this on config props. So as you go in and you define in your Spring profile all these properties, then you can hit the config props endpoint and get a holistic view of exactly what it is, what properties are configured, in your service. Let's see. In addition to the configuration classes themselves, a lot of times you'll see where the properties have been moved over into a properties class, and they're referenced via this enable configuration properties attribute. And so, for example, here for the Slack config properties, this data means that the getters and setters are automatically generated for you. And in the Spring profile, all you need to do is just say, slack.token or slack.base URL to go ahead and assign values to these at runtime through your Spring profile. In addition to the configuration classes, the other way to do this that's a little bit older, but is still present in some places in the code, is through the use of value statements. So in this case, you'll see configuration is still used, but down to set a value for a particular property, you may see value referenced like this. And so, in this case, the PagerDuty.token property in your Spring profile would be mapped to this particular property for to configure the PagerDuty class. So, yeah, going through both the Spinnaker code as well as sometimes it's useful to look at the Spring boot classes that are used as well. Like in a stack trace, you may be able to figure out a way to set a property and resolve your error without having to make any changes to the actual code. So,
as you can see today, we're a little further along. We've managed to grow our little proof of concept instance, as well as build other instances to keep up with Salesforce demands. So what's next? As we catch up to our requirements and growth targets, we'd like to improve the user experience in general. Maybe introduce some custom skinning, do some upstream improvements. We want to improve fault tolerance in general by making sure errors in integrated systems surface better. Pipeline failed for unspecified reasons is not a super helpful error message, and we'd like to improve on that. We run into transient errors as well, and users tend to rerun pipelines to fix them. And we'd like to see if we can make that better. We're also looking into active high availability instances. But we've got some concerns there. We've still got some issues to figure out. All right. Thanks for watching, and stay safe out there.
Thank you very much for coming out.